Hey everyone, and welcome to The Explainer. Today, we're taking what might honestly look like a super dry university physics syllabus, and we're going to reveal the invisible force that is literally powering everything around you. I mean, from the blender sitting on your kitchen counter right now, all the way to high-speed trains levitating across continents, there is a single fundamental force driving the whole shebang. So stick with me, because by the end of this, you're going to look at your everyday gadgets in a completely new light.
Right, so let's dive directly into our source material. We're looking at an actual Basic Physics 2 syllabus, specifically Meeting 11 by lecturer Prostio Eco Sasanto. We're going to break down these foundational academic concepts together. No fluff here, just the core scientific truths about how applied electromagnetism shapes, well, our entire modern existence.
Okay, here is our roadmap for today. 1. The invisible power. 2. Driving motors and generators. 3. Everyday electrical magic. 4. Medical and future tech. And finally, 5. The double-edged electromagnetic sword.
Section 1. The invisible power.
So, electromagnetism. It's basically the branch of physics that studies this incredible, intricate dance between electric fields and magnetic fields. You can kind of think of them as two sides of the exact same coin, right? They're constantly pushing and pulling on one another, which directly affects energy and waves. And this single phenomenon, it is heavily utilized across practically every sector you can even think of. Major industries, global comms, advanced healthcare, and transportation. It is everywhere.
Now, the absolutely crucial point here is a reciprocal relationship. This is the golden rule of our entire explainer today. An electric current flowing through a conductor actually generates a magnetic field. But, conversely, a changing magnetic field can generate an electric current. It goes both ways. This loop, this beautifully simple rule, it serves as the absolute foundation for every single piece of tech we're about to talk about.
Section 2. Driving motors and generators.
All right, this brilliantly illustrates that foundational flip I was just talking about. So, an electric motor takes electrical energy and turns it into mechanical, physical motion. How? Well, by using the Lorentz force, which is essentially a magnetic field pushing against an electric current to create a spin. This is literally what runs your desk fan or pumps your water. Now, a generator does the exact opposite. It uses electromagnetic induction to convert mechanical energy, think of a spinning wind turbine, back into electricity for the power grid. Motion creates electricity, and electricity creates motion. Pretty cool, right?
Section 3. Everyday electrical magic.
Okay, to get power from those massive generators all the way to your house safely, we use transformers. A step-up transformer increases the voltage while actually lowering the current. Now, why does that matter? Because a lower current reduces the energy that's lost as heat when electricity has to travel over really long distances. But you obviously can't plug your laptop into thousands of volts. And that is where the step-down transformer comes in, lowering the voltage back down to safe, usable levels. It's the exact reason the power supply adapter for your electronics might get a little warm, instead of, instantly frying your device. If you want to see this invisible force in highly visible action, just look at the rapid steps of a simple electric doorbell. It's this elegant 4-step process. First, you push the button and current flows. Second, that current hits an electromagnet, instantly turning a simple iron core into a temporary magnet. Third, that sudden magnetic pull violently snaps a metal striker forward. And fourth, the striker hits the bell, producing sound. And when the circuit breaks, the magnet disappears, the striker resets, and the whole thing happens all over again in milliseconds. And hey, electromagnetism isn't just about physical movement or ringing bells. Invisible electromagnetic waves, specifically utilizing radio and microwave frequencies, are what give us Wi-Fi. This breaks massive physical boundaries, allowing your computers and phones to connect to the internet, communicating just vast amounts of data without a single physical wire connecting them. It's basically invisible magic.
Section 4. Medical and future tech.
Now, think about that tiny desk fan from earlier, spinning because of a motor. It brings up a really fascinating question. How can the exact same principles spinning a small set of plastic blades actually lift and propel a massive, heavy railway train?
The answer is the maglev train. By utilizing immensely powerful electromagnetic forces, maglev trains completely eliminate mechanical friction with the tracks. I mean, the train actually levitates. Because there's almost zero friction to slow it down, this application allows these trains to achieve incredibly stable, high-speed travel that traditional wheeled trains just simply cannot match. It's a real game changer for transport. Shifting gears from transportation to modern medicine, we see another brilliant application: the MRI, or magnetic resonance imaging. MRI machines combine massive magnetic fields with radio waves to safely look inside the human body. As the syllabus highlights, the incredible advantage here is that it produces highly detailed images of our internal organs without exposing patients to any harmful X-ray radiation. It is purely the magic of electromagnetism at work to save lives.
Furthermore, we actually fire these exact same types of waves out into the sky as radar. Radar systems emit electromagnetic waves that literally bounce off physical objects. By measuring how those waves return, we can instantly calculate the precise distance, position, and speed of airplanes, ships, military targets, and even incoming weather systems. Instant math, all thanks to invisible waves.
Section 5. The double-edged electromagnetic sword.
Look, there is absolutely no denying the positive impacts here. Electromagnetism has made difficult human labor incredibly easy through automation and robotics. It drives all modern instant communication. It facilitates life-saving health tech like the MRI, spurs rapid technological development, and allows for maximum industrial efficiency on a global scale. I mean, it literally built the modern world.
However, the syllabus impartially points out the dark side of this coin. With all these advancements, we now face potential negative impacts. We have to monitor radiation risks to human health. We're constantly battling electronic signal interference. We're contributing to what's known as electromagnetic pollution in our environment. And perhaps most notably, we have developed a total unyielding technological dependence on this power grid. Which brings us to the end of our explainer today, and leaves us with a pretty profound realization. As you sit there right now, surrounded by glowing screens, wireless routers, and modern conveniences, remember that we are completely reliant on an invisible physical force to run every single aspect of our modern lives. The push and pull of magnets and electricity is the heartbeat of society. So I'll leave you with one final, slightly terrifying thought to chew on. What happens if it all just stops? Thanks for joining me on this journey through the syllabus, and I'll catch you on the next explainer.